लेके नहीं लिख रहा है नहीं। हाँ वो अपने आप ही बंद हो गया। एक मिनट बैकग्राउंड में ये आ रहा है, मैं इसको बंद कर दूँ। हो गया। हाँ हो गया। हाँ हाँ टास्क मैनेजर बंद कर रहा हूँ मैं उसको। हाँ उसमें उसमें बंद हो गया, नहीं आ रहा उसमें। नहीं आ रहा, बंद हो गया। ओबीएस को मिनिमाइज किया। अब मैं लाइव में गो लाइव कर रहा हूँ। मैं गो लाइव कर दूँ ना।
Good morning, viewers. Welcome to this session on control statements, arrays, and functions in C programming. In the previous session, we had seen the basic constructs of C programming. So, in that particular session, we had covered block 1. In this session, let us concentrate on MCS 011, problem solving and programming, block 2, control statements, arrays and functions in C programming. So, a program consists of a number of statements to be executed by the computer. Not many of the programs execute all their statements in sequential order from beginning to end as they appear within the program. So there may be some instances where in which instead of please hold. नहीं ये कीबोर्ड
वो माउस से कीबोर्ड से क्या एरो वाली चीज से होगा। आपका वो चल रहा है।
Sorry, there is certain technical error. Please show the slide. Please hold on. I will be starting the session very soon.
पीछे स्क्रॉल चल रहा है।
Sorry, within few minutes we'll be starting once again the session. There is a technical glitch. Please hold. दोनों है।
हाँ हाँ इसको देखिए चेंज कर दिया नहीं उसे नहीं आप बोलते रहिए तो कुछ भी बोलते आप चलते रहिए ताकि जो है लाइव जाता रहे आपका मैं चेंज करता हूँ नीचे करो डाउन करो उसको सर मैंने चेंज कर दिया मैंने चेंज कर दिया शेयर कर दिया सर इसको हमने स्लाइड चेंज कर दी मैंने वहाँ एक्टिव करके उसको चेंज किया यहाँ से एक्टिव हो गया मैंने कहा स्मूथ है कर दिया कर दिया हाँ मेरे पास आ गया एक्टिव है एक्टिव का एक्टिव मैंने किया ना दूसरी स्लाइड लेके आया ना मैं ठीक है किसको कीबोर्ड से डाउन करिए कीबोर्ड से हाँ ठीक है अब ऊपर देखिए ना स्लाइड ठीक है ऐसे देखिए चलो ऊपर हाँ हो रही है मुझे सैनिटाइज बंद करो एक मिनट करिए सर स्टार्ट कीजिए सर स्टार्ट कीजिए
So welcome back. Sorry, there is some technical glitch over here. So let me start the session once again. So good morning viewers. I welcome you all to this particular session. In the earlier session of MCS 011 we had seen block 1 of MCS 011 and in this session we will see block 2. The block 2 consists of 4 topics. One is the control statements, second is the string functions, third is the arrays and then fourth is the functions. So a program consists of a number of statements to be executed by the computer. Not many of the programs executes all their statements in sequential order from beginning to end and they appear within the program. A C program may require that a logical test be carried out at some particular point within the program. So whenever we see the programming languages, we write the program, we follow the syntax, but in the program itself, depending upon the logic, there may not be a sequential flow. Right from the start till the end of the program, there may not be the sequential flow. However, there may be certain decisions and basing upon the decisions, some set of statements needs to be executed, or else if it doesn't fulfill, then it has to be skipped out and then it has to follow a different kind of set of statements. So let us see in this particular program the control statements, arrays and functions of C programming. I am Professor V.V. Subramaniam, Director, School of Computer and Information Sciences, IGNOU, New Delhi. So one of the several actions will be carried out depending on the outcome of the logical test, as we see when we write the program. This particular activity is called as branching. And in the selection process, a set of statements will be selected for a execution among the several sets available. So if S is there, then it should execute a set of statements 1. Then if no, or else we can tell it as false, then we have to go to a different set of statements which needs to be executed by the program. So if there is a need of a group of statements to be executed repeatedly, In some instances, we may be having a particular context wherein which we need to execute the set of statements repeatedly, and that particular activity is called as the looping. So looping is carried out in the programming whenever we have certain statements which needs to be executed in a repeated fashion. These control statements determine the flow of control in a program and enable us to specify the order in which the various instructions in a program are to be executed by the computer. Normally, high-level languages follows 3 sets of instructions, namely sequence instructions, selection or decision instructions, and then repetition or loop instructions. Sequence instructions, suppose if you want to consider a program wherein which you have to take two integers from the user, add them and display the sum of them. Here there is no condition, or else here we are directly taking 2 inputs from the user, we are summing them, then we are displaying the sum of the 2 variables. So here it needs a kind of sequential operations. However, if you want to check for a decision kind of thing in between, suppose if you are not allowing a negative number, so once again it is a kind of decision, and then you have to have a set of instructions in place wherein which it may be routing to some other else. So in this particular context, a sequential instructions from start to end, maybe one of the thing is just to write a simple program is some kind of thing. Suppose if the decisions are involved, then we can have the decision or else the decision kind of statements in the programming languages. The select instructions, select means executing different sections of code depending on a specific condition or the value of a variable. This allows a program on different conditions, and C provides 3 select structures, that is if statement, if else, and then switch case statement. So all these 3 statements supports the select kind of instructions. So basing upon the select kind of instructions, the condition may be either true, a set of instructions will be executed. If at all it is false, then another set of instructions needs to be executed. And then coming to the looping constructs, in C you have while, do while, and then for kind of looping constructs available. So looping constructs means executing the same section of code more than once. A section of code may be either be executed a fixed number of times of while some condition is true. C provides 3 looping constructs. As I told you, the first one is while statement, second one is do while statement, and third one is for statement. So there are not only one simple if statement, however you have 4 different if statements. So 4 different if statements of implementation are: one is very simple if statement, means if a condition is met, then the set of statements needs to be executed, and then it will comes to the next flow of statements. Then another kind of thing is there wherein which it talks about the if else. If the statement is true, then it executes a set of statements. If the expression is true, then it executes a set of statements. If it is false, once again it goes back to the next set of statements. So there we will have to have a kind of if else statements. Then there is another context, a nested if else statement, and the 4th type of if statement is the else if statement. All these if statements, different forms of if statements, let us go one by one with the example. So please open your presentation that I had already forwarded to you on the Facebook. You can have a look, because yes, now here the PowerPoint presentation has started. So these are the different forms of implementation of if statements we are talking about. One is the simple if statement, Second is the if-else statement, nested if-else statement, and then else-if statements. So just see the syntax of the simple if statement. If we write within braces condition, then statement or set of statements. If you look into the example, if x less than 0, printf, we are printing the x. This is a simple if example of a simple if statements. Just see the flowchart here. If the condition is met, means we are checking the condition using if. If it is true, it will execute the block of statements. Else, it will execute and go to the flow of the program. So just have a look into this particular program. Program to calculate the net salary of an employee. Here we are taking gross salary and net salary as float variables. We are prompting the user to enter the gross salary. We are scanning it into the program, means we are taking the salary that is being given by the user into the gross salary variable. If gross salary is less than 10,000, directly the net salary will become the same salary that the person has inputted. If the gross salary is greater than 10,000, then there is a simple calculation wherein which we are deducting 0.5 into gross salary. So that will become the net salary for the employees whose salary is more than 10,000. So here in this program, we are using two simple if statements. We are not using any else statement or anything else. We are checking against the condition whether the salary is less than 10,000 or greater than equal to 10,000. So the another construct is if else statement. If condition, then it executes. If the condition is checked, if it is true, statement 1 block is executed. Else if the condition is false, then it goes to statements 2 block. It executes the statement 2 block. After the execution is over, straight away whether it is true or false, correspondingly the statements 1 or 2 will execute and will come back to the statement 3 block. That is the flow of the next line of the program. So let us depict this particular thing in the form of a flow chart. So here condition is tested. If at all it is true, it is executing statement 1 block. If it is false, it is executing statement 2 block. Then obviously after the execution is over, then it is coming to statement 3 of the flow of the program. Let us see a simple example over here. This is a program to print whether the given number is an even number or odd number. So whenever we talk about an even number or odd number, how we will find? We check against whether it is divisible by 2 or not. So here I am taking a number from the user. I am checking against whether it is divisible by 2 or not. Here I am using, let us see here. I am using the mod function. X mod 2 is equal to, here I am putting 2 is equal to, because I am checking the condition here whether it is giving the remainder is 0 or not. If at all it is 0, the given number is even number. If at all it is false, then the given number is a odd number. So this particular program illustrates you a simple if else condition. If it is divisible by 2, it prints it is an even number given by the user. If it is false, then it is an odd number. Let us come to the third construct, that is else if statement. So in else if statements, what we are seeing here is condition 1 is checked. If L, if S, then it enters to statements 1 block. Else if condition 2, it executes statement 2. Likewise, it goes on, keeps on checking, and if the conditions are true, then only it will enter into the statement block. So just see here, it is a simple flow chart. If the condition 1 is there, true, it executes statement 1 and come back. If false, then it checks for the condition 2. If the condition 2 is true, then it executes statements 2 block, it comes out. Otherwise, both of them are false, then it goes to condition 3. Likewise, whenever there is a false kind of thing, it is keeps on moving to the next conditions, and if those conditions are met, it is trying to execute the set of statements that are given under, or else it is once again moving to the next condition check. So there is another construct in the if statements, that is nested if else statements. If condition 1 is checked and it is true, and if condition 2 is also checked, then it executes statements 1 block. Here 2 conditions are being checked. Condition 1 is checked, true. Then if condition 2 is checked, then again as that condition is also true, then only it will enter to the statements 1 block. Or else if the condition 1 is failed, you can see here else statement 2 block. That is meant for the condition 1. Likewise, that is meant for the condition 2. And then there is another else statement that is corresponding to the first one, wherein which statement 3 will be executed and it will comes out of the block. We can see here another construct called as the switch statement. So switch statement is nothing but, we had already seen the previous statement called as the nested if, or else we had seen the else if statement. So instead of writing so many else if statements, you can directly go to a switch statement, wherein which the objective is very clear. It is to check several possible constant values. That is the expression. You can see there, switch is the keyword, and within that particular keyword we are using expression. So that is the value. So depending upon the value that we get into that particular expression, it directly moves to the case. Suppose if the expression value is, or else take for example a simple option program, a kind of a program, menu driven program, wherein which you are asking the user to key in 1, 2, 3 for the options to be executed. Suppose if the expression is capturing 1, then there may be a case against 1. These are the set of statements needs to be executed. Suppose if the case is 2, that is option is 2, a set of next statements may be executed. So here the control of the program is directly going to the case statement, wherein which the block of instructions are straight away written, and afterwards for each and every case statement you can see the syntax over here. I am using a break statement, means after the execution of that particular case, whatever the value that you had given, then it directly executes the block of instructions. Then there is a break statement which comes out of the complete switch statement. So for that reason we have to write the break statement, otherwise it keeps on checking the conditions and it executes. So here you have to remember that for each and every case statement you can see here a break statement also has been written. Let us see a simple program. This is the program that is listed over there, a program that performs the following depending upon the choice selected by the user. So if the choice is 1, calculate the square of the number. If choice is 2, calculate the square root of the number. If choice is 3, calculate the cube of the given number. So otherwise, if all the 3 choices the user hasn't selected and he has selected a different kind of choice, then it should print only the number as it is and it should come out. So this is the program for that particular problem statement. So here the user, we are asking the user to enter any number of his choice, that is from 1 to 3 or else anything. So depending upon the choice, if the choice is 1, you can see thus after switch there is a simple variable which is capturing the value or else the menu or value of 1, either 1, 2 or 3. So if the choice is 1, choice is 2 or choice is 3, all the cases I had given over there. So if the choice is 1, you can print the square of the number. If the choice given by the user is 2, then the square root of the given number is to be calculated. If choice is 3, correspondingly the cube of the given number is calculated. Suppose if it is not been either 1, 2 or 3, and if the choice is something else, then it should display the number as it is and then comes out of the program. So instead of using several nested if statements, you can use this particular switch statement, is straight away programming construct, wherein which depending upon the choice given by the user, you can execute the following set of statements corresponding with the choices given. Then there is another construct called as the while construct. So here in the while construct, you will check the condition while some condition, then set of statements will be executed, then there will be a control variable. Here you can see there is a control variable wherein which it may be either increment value, we will give the increment value or the decrement kind of thing, and then once again it will be, the condition will be checked, and then it executes the statements till it fails the condition. For example, here digit is initialized to 0, it is an integer variable, and then while digit is less than or equal to 9. So that is where the condition comes into picture. Till that particular condition fails, it executes, it enters into the loop and it executes with the increment of 1. So first it takes, it is checked 0 is less than or equal to 9, then printf the digit, that is 0 will be printed. Once again it is incremented by 1. Once again the condition is checked, then 1 is less than or equal to 9, 1 will be printed. Another digit is incremented by 1, then 2 will be printed. Likewise, till it meet less than till it meet 9, the following loop executes, and then after that if the condition is failed, then it comes out. So let us see a simple flowchart for this while statement. Here condition we are checking, while condition, if it is true, it is entering into the execution of some block of statements. If it is false, directly it is coming out of the loop. So here a simple factorial calculation is given over here in the as a second example. Enter any number to find the factorial. We are scanning that particular number given by the user. While x greater than 0, we had written the set of statements over there, and x is incremented by, x is decremented, and then it is calculating, and after the condition is failed and it is whenever it meets 0, then it directly prints the factorial. Another form of while statement is there, that is the do while statement. In the while statement, first of all, while executing the while statement, it first of all tests the condition. Then only if it is true, then only it enter into the loop, execute the statements, then if the condition is false, then it comes out of the loop. But that is not the case with do while. There is a simple alteration in do while, wherein which for the first time it directly enters and executes the statement, and then only later on it tests the condition. Just see the syntax over here, it is not checking any conditions for the first time. Do directly execute the set of statements that are given within the braces, and then while test condition. So here the condition will be tested, and whether to go or whether to quit from the loop depends upon the true or false of that particular test condition. If at all it is true, once again it will execute the statement, and then if at all it is false, it comes out of the loop. So for at least once if the loop needs to be executed, then we have to write the do while statements. Here the complete this one is given in comparison with the while statement. It is a similar to while loop. However, the only difference is that the expression which determines whether to carry on looping is evaluated at the end of each loop. So for the first time it enters, it checks, the body of the loop is executed at least once before the condition, then the loop repeats body, as that depends upon the condition whether it is true or not. However, in while loop, the statement doesn't execute the body of the loop even once if the condition fails at the first time. But here it is entering at least once, it executes, then it checks the condition. If at all it is true, once again it goes back and do, otherwise it comes out of the loop. So a simple example is given over here. digit is equal to 10, that is integer data type I had taken, then do printf percentage digit while digit is less than or equal to 9. So here even though the condition is failing, then also it will print 10 and comes out. So this is a simple flowchart construct given for the statement do while. At least once it enters the body of the loop, then the condition is checked. Otherwise this is a kind of reverse, where in which in while condition is checked, then only the body of the loop will be entered. So the third construct here we can discuss is the for loop construct. For loop is, you can see the syntax over here. First the initialization is done for the variable, then variable or variables, then test condition, increment or decrement, then a set of statements are executed, and then if the condition is failed, it comes out of the loop. So this is the syntax for the for loop. So this is a simple flowchart given for the for loop. So initialization, then condition is checked, true it executes the set of statements, and if it is false it comes out of the loop. So for loop and while loop you can use it interchangeably, but do while loop you have to think, then only you have to use the do while loop. Instead of for, many people use while loop, and most of the people, they are very much accustomed with the for loop and they leave the while loop behind. Here is a simple program in order to illustrate the for loop. Here print value of n, printf enter the value of n. We are taking the n value from the user. The first n natural numbers we are trying to print over here, and then whatever the n value, till that n value, all the natural numbers are being printed here in this program as the output. Like n, suppose if the user is giving 10, so likewise it executes the lab and the uppermost limit that it is taking as 10, and if it is equal to 10, right from as the initialization we had done over here is I is equal to 1, so from 1 to 10 all the values are printed and it will comes out of the loop. You can see here for I is equal to 1, here the initialization is done, I less than or equal to n, here the condition we had given, and then plus I, here we are incrementing the value of I for each and every iteration. So here I will be set to 1, first it prints 1, then it goes back with the increment of 1 value, then 2 will be printed. Likewise till the condition, if the user has given 7, then it will print still 7. Then coming to the nested loops, there may be a question whether we can use the loop within the loop. Yes, it is possible. Suppose if you want to take the inputs for a matrix, 2 by 2 matrix. So you have to take the inputs row wise, then go by column, then enter into the next row, once again all the column values, then enter into the third row. Likewise we have to capture all the data from the user. Even this is true for the printing also. You have to print value by value, that too with the matrix value by value, where in which the nested loops works over here. If the matrix is 2 by 2, then you will be taking 2 loops within itself. Like here I had given a simple construct over here for I is equal to 0, I less than 10, I plus plus. Then another thing is for the first initial stage it takes 0, enters, j is less than 3. So till that particular point it prints all the things. Once again it takes the value I incrementation of 1, then it takes I is equal to 1, it enters into the j loop. Likewise all the things till 9 it will take. So this is meant for you, just use the constructs that I had given to generate the following pattern given below. In the first row only 1 needs to be printed, and in the second row 1, 2. Likewise whatever the end that the user prints in, the pattern needs to be followed till that n value. Then there is an interesting statement called as the break statement. We had seen this particular break statement when we are writing the switch case. So switch, suppose if you don't write the break statement for each and every case, then it sequentially execute all the statements. It checks all the conditions, it will directly goes into the next statement also, it will likewise it will go till the end. Suppose if the break statement, wherever it enters into the, it encounters the break statement, it is used to terminate a loop, or it may use for the exit at that particular context. Like it can be used within a for, while, do while, or a switch statement. Normally we have a practice wherein which we normally use this particular break statement whenever we write the switch statements. It is used to terminate a loop or to exit from a switch statement in a convenient way when a condition is met, executed the statements. If any error or irregular condition is detected, then it will comes out of the loop, or it will execute from the switch statement. Here a simple illustration is given over program to calculate smallest division of a number. So the user, we are asking him to enter a number. Depending upon the number that he has entered, we are checking which is the smallest divisor. Here we are not asking the set of divisors, or else whatever the divisors that are there, in order to display all the divisors, we are not at all writing this program. There is a context over here. We have to print only the smallest divisor. So smallest divisor only one single smallest divisor. So here the user is entering the number, then that particular number is being scanned and then checked against, so whether it is divisible by any of the thing, and whichever is the smallest thing that is encountered, then and is been giving the remainder 0, that particular thing is called as the smallest divisor, and that smallest divisor we are printing and coming out of the program. Till that particular I we are meeting over here, so it executes, and then whenever it gives the value like 0, the remainder 0, it will print the smallest divisor of that particular given number. There is another statement called as the continue statement. It is used to bypass the remainder of the current pass through a loop. Suppose if the loop is continuing, and there may be a case wherein which one particular variable's value needs to be skipped off. So in order to print, suppose if the program is to print the natural numbers right from 1 to 10, but you have to skip 5. So it should print only 1, 2, 3, 4, then 6, 7, 8, 9, 10. So in order to meet that particular condition, you can skip the value whenever it reaches I is equal to 5. You can skip that particular value to print, and later on you can continue with the next, that is the print of the 6. So it is used to bypass the remainder of the current pass through a loop. The loop does not terminate when a continue statement is encountered. However, it skips that value. Once again, it goes on to the loop with the next value. Let us see this particular continue statement with an example. Program to print first 20 natural numbers, skipping the number divisible by 5. So it should skip 5, 10, 15, then 20. So all these numbers needs to be skipped, and only the remaining numbers needs to be printed. So here I am checking the condition wherein which if at all it is divisible by 5, then it should not be printed. So see here, I mod 5 is equal to 0, then continue. It should not be printed. Otherwise, it will go to the next statement, that is printf %t, I. So such kind of context wherein which it needs to skip certain values depending upon the condition, then we use the continue statement. Let us go to the next statement, go to. The go to statement is used to alter the normal sequence of program execution by transferring abruptly the control to some other part of the program depending upon the label that we are giving. However, in C programming, the go to statement, usage of go to statement is a bad practice. So mostly because it may give some other values and it may take out the like the logic whatever you are applying in some or other ways, this particular go to statements needs to be used very cautiously. Otherwise, whatever the like a sequence that we are going to follow may be missed, and some other outputs may be given other than the outputs that we are thinking for. So this particular go to statement needs to be used very cautiously. Although go to statement is used to alter the normal sequence of program execution, but its usage in the program should be avoided. As I told you, the most common applications are to branch around statements under certain conditions in place of use of if-else statement, to jump at the end of the loop under certain conditions by bypassing the rest of statements inside the loop. This is abruptly doing and coming out of the loop, and to jump out of the loop avoiding the use of break statement. Then also you can go, instead of using the break statement, you can place a label, and that particular label you have to match with the go to label, and directly the control comes after execution of the statement. Whenever it counters the go to statement and the label, then it comes out of the loop and then it executes the next statements. Just see a case statement here, or say a simple example. Sum is equal to sum plus I. If I is equal to 7, then go to addition. That is the label that we had provided, and addition, the label against that addition we had written printf %d sum. So even though the condition, you can see there, int I is equal to 0, I less than equal to 10, that is the limit. 10 is the limit that we are keeping, and then I plus plus. So it should execute the loop for 11 times, 0 to 10, less than or equal to, it's 11 times. However, this is not executing. Why? Because if it encounters the condition I is equal to 7, go to addition, means till 7, till 6 it will do 0, 1, 2, 3, 4, 5, 6. It will find out the sum 0 plus 1 plus likewise, and then if at all it encounters I is equal to 7, it is breaking and it is coming to the label addition. There the print of sum. So only digits from 0 to 7 are being added and printed as the sum. We are not going till the 10. Then comes, so with this particular thing, we had covered the control statements. Like in the control statements, we had seen several if constructs. We had seen the switch statement. We had seen the looping constructs like while loop, for loop, do while loop, and then we had seen continue statement, break statement, go to statements, and all these constructs, syntax along with the examples we had seen till now. So in order to go to the next chapter, that is arrays, consider a scenario where you need to find out the average of 50 integer numbers entered by the user. So suppose if all these 50 numbers needs to be stored in the form of variables, you require 50 variables to be initialized. And there is another way to do that particular thing, like having a single integer array to store all the values, loop the array to store all the entered values in an array, and later on calculate the average. So in the C programming, whenever you see, there are several variables you will be requiring. So for using the like looping constructs, for initializing certain variables, certain values, so there we are using the variables kind of thing. Suppose if a class strength of 40 students are there and 7 subjects are taught, and in order to capture all the students 7 subject marks, you will be requiring those many integer variables to be added into. So instead of having those many variables, you can have a simple array for the students, and for a simple arrays initiated for the marks of each and every subject. So which is the better solution? In order to take those many variables into the program, by identifying the data type, or else this particular problem may be like sorted out using a single identifier with an index, that is an array with the index. So obviously the second solution, it is convenient to store the same data types in one single variable and later access them using array index. So let us take the previous example itself. Suppose if the English marks for 40 students needs to be taken care, so I'll write English as the identifier with an index of 40. So it will start from 0, English of 0 for the first student, capturing the marks of English. Likewise, for all subjects, I can take similar 7 identifiers with the indexes, that is 7 arrays, and then I can capture the marks of all those students. Otherwise, for English, you have to declare 40 variables. For a second subject, you have to declare 40 variables. Third subject, you have to declare 40 variables. Likewise, it will be a clumsy and nobody, you'll be making out a mess in the whole programming in order to find the total or average of the marks of each and every student. So how to take an array into consideration? What are the features? What are the characteristic feature of the array? In order to declare an array, it requires two things. One is the data type and other is the index. And third, as you know, it is an identifier or else a kind of label, or else just you give the variable name. Likewise, you have to name the array also. So here you can see I had given two examples. One is NUM, that is the array with 35 elements, and I am declaring that particular array with a data type that as an integer. So this num array with 35 elements, all the 35 elements will have integer values only. So there won't be any mix, only integer values it will take. Likewise, a character ch of 10. This is an array of characters of 10 elements. As you had seen, there are 4 basic data types: integer, character, float and double. So the array may be either integer, character, double or float array. Just see an example. Program to print first 20 natural numbers, skipping the numbers divisible by 5. So this is the thing which illustrates you earlier, but most probably this is not. An array is a group of same data types that we had already seen. Either it should be containing all the integer values, float values, double values or character values. For example, an integer array holds the elements of integer types, while a float array holds the elements of all float types only. So the characteristic features of an array are: it is a data structure storing a group of elements, all of which are of the same data type. There won't be any mix. If you are declaring them as int, then it holds only integer values. All the elements of an array share the same name and they are distinguished from one another with the help of an index. So here the index plays the main role. Suppose if an integer array of NUM containing 35 elements, so it will be maintained or accessed using the index value 0 to 35. So then comes a random access to every element using a numeric subscript. Like suppose in order to access, suppose if the index array, suppose if I am starting the number array from 1 to 35 and in order to access value of 23, so NUM 23 will be giving you the value of that particular element, value of that particular num of 23. So normally the subscript starts with 0. So here whenever by default in C programming the array subscript starts with 0. Here you can see the program to find out array average of 50 integers, and then NUM of 50. So it is declared, num is declared as an array carrying integer data type, and then we had in order to capture the values of 50 from the user, we are using here the loop construct. So one by one the value is being entered by the user and it will capture from 0, NUM of 0 till NUM of 49. So all these values will be captured and then the sum is calculated, and then average is equal to sum by 50, and it will display the average. Otherwise, you have to take 50 variables in order to capture 50 values from the user. Then you have to find the sum and average. So this is the best thing you have to follow, and it avoids the length of the program, it avoids the execution kind of thing, it avoids total confusion, chaos in the programming whenever we use such kind of constructs in the C programming. So array initialization. So arrays can be initialized. Suppose if you are taking an array of integers. Here I had given you a simple example, int digits, and the subscript given over here is 10, and I am capturing 10 values. Suppose if the arrays I am not asking from the user, and if I myself wants to initialize the whole array in the program itself, then also it is possible. And the syntax that you will be using in order to declare the array with the values is data type, array name, size is equal to, you have to use curl brace, and you have to give the values, and then should end with the curl brace, then semicolon. So if it is having 10 as subscript, give the values of 10, and then it will take as digit 0 as 1, digit of 1 as 2, likewise it until 10. If nothing is being given in the subscript or else as index, you can see the second example over here, int digits, within the square brackets the index is not provided. That itself indicates that whatever the values, the number of values that we are going to initialize on the right side, you can have a look over there, 1 to 10. So all the 10, like by default the array size will be 10 integer digits. So if you are not giving the index over here, by default it will take the number from the right side. Likewise, you can have the float values, you can have the double values, and either you can initialize them directly into your program also. Then comes the character array initialization. So the character can be initialized. The character array is also called as a string. So here, in order to initialize the character array, you can see thing of 3, and then it should be written within the double quotes. So a special character called null character implicitly suffix every string. This is the thing that you have to remember. So in order to have a character array, then automatically a null character, that is /0, implicitly suffixes every string. Then let us see the other concept called as the function. In C programming, we can call the main program as the C program or else C main function. Or else there are well-defined functions also, like string functions. They will come ready-madely. Whenever you want to find the string length, whenever you want to concatenate the string, there are ready-made inbuilt functions in C. Like printf is a function, scanf is a function. Likewise, there are several inbuilt functions which we will be using. Suppose if you want to write by yourself, those are user-defined functions. So why we use the functions? The use of user-defined functions allows you a large program to be broken down into a number of smaller self-contained components, each of which has some unique identifiable purpose. That is not only the thing, the C program can be modularized through the intelligent use of such functions. And then the third use of the function is avoids the need of repeated programming of the same instructions. Suppose if you want to find square of a number, and that particular square of the number you have to find at least 13-14 times in the C program. Better to write a square function, user defined square function, for one time, and then with different values you can use that particular square function by providing the context wise values. So in order to avoid the repeated programming of the same instructions, we have to use the functions. Otherwise, we achieve the modularity in C programming by using the C functions. When you use this particular functions concept, you can have a clear cut and like clarity in the programming. The main function at one place, then the user defined functions either at the top or else at the bottom we write. And whenever there is a call kind of thing from the main program, the control goes to the function with the values or else with the parameters, if at all they are there. It executes and then comes back after the execution is over to the, and the control is being taken back by the main program. Likewise, the complete flow will be organized. So better you write functions whenever there are repeated programming kind of instructions to be written in the C program, in the same program. So if function is a self-contained block of executable code, when you see a C main program or a C function, you find several similarities. Like it itself is a self-contained block of executable code. In many programs, a set of statements are to be executed repeatedly at various places in the program, and may with different sets of data, the idea of functions may come into your mind and those can be executed. You can keep those repeating statements in a function and call them as and when required. When a function is called, the control transferred to the called function which will be executed and then transfers the control back to the calling main function. You can see the syntax over here. Whenever you want to write the user defined function, the syntax of a function is return data type. Suppose if the function is returning an integer value, you have to write int, then function name, list of arguments, or else you can call them as the parameters, and then within the function the data type declarations of the arguments that you have to give, whatever the value, whatever the variable that you want to use in that function, you write those like declarations of the variables, then some executable statements, and then the return expression. So this particular return expression or the return value, whatever that we are taking here into consideration, there you can see at the top RETURN, a keyword has been used over there, that return data type. The return data type should match with the value return expression. So this you have to keep in mind. Suppose if nothing is been written from this program, only simple printf is there, then you can use a void, void. So if nothing is been written from the program, from the function, from the user defined function, we have to use the return data type as void. Void, function name, some parameters, write the thing, and this particular function won't return any value, but instead it will display something in the printf statements. Like if it wants to return the integer value, you have to write int, then function name, list of arguments, and you can continue with the programming like functioning concept. Just we will go through a simple example before concluding the session. Include stdio, then main program, and then here there is a square function. So the main function is very much clear. We are not mixing both the things. And this is a simple program. However, this square function may be used some 30-40 times in the main program with different values or different parameters. Then you can use this particular thing at various contexts in the main program. Like here, an integer is been returned to the main program. So if you see the user defined function square function at the below given int square int no, that is the parameter. So it is capturing, and then result is equal to the square number into number, then return the value, and this particular value is being taken back and is assigned to SQ of the main program. Suppose if the result needs to be displayed over here in the second user defined function itself, and no need of giving back the control to the main program, there you can write the printf statement also, and instead of using the return data type as int, you can use void square int number, and the printf statement may be included here in the user defined function itself. So there are three categories of functions we can talk about. Functions with no parameters and no return value. We'll be calling the function. Obviously the control will goes to the function and there won't be any return value. However, a kind of printf statements may be placed in that function, and then and there itself the values will be displayed, and there is no control given back to the main program. That is one category of function. The second category is it will comes with certain parameters and value won't be, the calculation will happen, or else the execution will happen in the user defined function, and no return value will be given back to the main program. However, the print statement we may be including in the second kind of category function. The third one is with parameters and with return value. You can see in the earlier example that it is coming with some parameter, it has been executed and returning back the value to the main program or main function of C. So here both the things are happening. It is coming with the parameters, the function is called with the parameters, and the return value is also being handed over to the main function, and it is displayed in the main function. So hope you understood all the concepts, all the constructs that we had discussed over today. We had started with the control statements. All the control statements we had discussed, the if constructs, all the four kinds of if constructs along with the example we had seen. Then the switch statement, how to use the switch statement, where to put the break statement in the switch statement, that we had seen. Then we had seen various constructs like looping constructs, the for loop, the while loop, the do while loop, along with the examples we had seen. Then what are arrays and where to use these arrays? What are the advantages that we are getting from the arrays? How to declare them? How to initialize the values to them? Where to use them? What are the characteristic features of arrays? All we had seen. Then what is the difference between the main function and the user defined function? That we had seen. Where to use the functions? How to use the functions? How many categories of functions are there? That we had seen in this session. Hope you had understood this particular session, and mostly whatever I taught today, it is like the whole gist of the second block of MCS 011. Apart, we haven't studied the strings that you can go through. What are the user defined functions? What are the ready-made functions that are there in the strings that you can see directly from the block itself? And in the next session, let us see the third block, which have the pointers, the structures, unions, file handling, etc. With this, I conclude the session. Thanks for watching. Give me the comments, and wherever you have doubts, please put on to the comments box so that I will go through the comments and then I will revert back to you by answering those comments. If at all you misses this particular class, once again I will provide the URL on the IGNOU SOCAS Facebook so that you can